Welcome everyone. I'm happy you could attend this webinar about FEM-Design 17. There are a lot of new features in FEM-Design 17, as many of you have already seen. Today we're going to take a look at the major features that come with this version. My name is Flavio Popescu. I'm a civil engineer at Strusoft, Denmark. And I am going to turn off the webcam for the rest of the webinar. Just wanted to introduce myself and now make sure that the internet connection is going well. So I'll just turn it off. So as I was saying, the correct model tool can be found in Tools, correct model tool, or in the left tool tab in the program in the FEM-Design screen. So a good way to start is to select your model and select all of these operations. As you can see, there are several correction tools that you have here. If you hover the mouse button over them, there will be a small tooltip that will show you, give you a graphical representation of what these features do. You can start by selecting all of them and click Start. And they will be identified as geometrical issues. You have the options to ignore, mark, or fix. If I can also have the option to choose Fix All, for example, and the program will do what it thinks is best for the structure. So I have this option to correct the model automatically and let it up to FEM-Design to decide what to correct. Well, all of the operations will be corrected, but this is not encouraged, especially if you have a big model. You can click Auto, and this is a great way to identify what errors there are and where they are. If I hit reset, everything is back to the initial, and I can go ahead and choose I can choose what operations I need because now I know where my errors are. I can just do it one more time so I can actually show you. You see there will be a number in the fixed column showing me that there were 4 errors in the align to structure grid correction. So I know that there will be a align to structure grid problem. So to continue with this process of correcting my model, I can just select the operations that I actually want to control. So this Fix All and Auto and allowing the program to just go through all the errors is a good way to identify the errors, especially if you're working with larger models. As when it comes to correcting the errors, it's best to do it one operation at a time and see exactly what the program is doing. This I make sure that I have full control of the correction tool, of this correct model tool. There are several operations that happen here that I can see here. These are common geometrical errors that happen, especially I've had some support cases where people have drawn after AutoCAD files, which is a very common geometrical errors are very common when drawing after AutoCAD files. Of course, making sure that the model is consistent is the first step, but errors still may appear, and this is a good tool to use. For now, if I just say fix all to all of my properties, to all of my operations, the program will fix them. I just need to click apply and click OK. If you have any questions, please type them in the questions section here. I won't go too much into detail with all of these features. I will show them, and hopefully you get an idea of how you can use them on your models. I think I will move on to the next feature. I have some models prepared, and I will talk about the composite cross-section. This is another new major feature in FEM-Design 17. The ability to define a composite cross-section for my bar elements. Let me just hide the control panel for now. So in the structure tab, under my bar elements, I have beams and columns. And when I set my default settings under section, I will have the option to choose composite. Here I can choose from a list of predefined sections of composite cross sections. And I'm going to use this one for my example. I can also give it a name, choose the steel material, just as I would choose the material normally, and then concrete, and then my size of the steel section. If I hit calculate, the geometrical properties will be generated by FEM-Design, and I'm ready to use my section. So then I can go ahead and apply it on my model, and I can use it as a bar element, and I can calculate the right deflections with the correct stiffness of this composite cross section. Again, it's pretty straightforward. I won't go into very much detail. We can have courses. We do have courses and more in-depth training for specific topics that you would like to discuss. All right, let's move on to the next feature that I want to show, which is the post-tension cables. You can now define post-tension cables in FEM-Design with the release of this new version. These post-tension cables can be defined for bars under the bar components. And I have here post-tension cable for bars. I'm going to turn on the 3D view so I'll have a better view. And I have here my structure, and I have a beam here. So I can also choose line by selection to define my cable. I don't think I select the correct line. Okay, so yes. choose it like this as a line, and my cable is generated into my beam. I can have this for bar elements, and of course I can go to properties and then edit my post tension cable, but I'll look into this a little bit later on. I want to go ahead and check my post tension cables for shell. So in the structure tab, of course, under shell components, I have post tension cable for shells. When I define them, I have several options to define them. I can just turn off the 3D view for now. So I can choose my plate and then draw my cable like this. And I also have the option to do a layout wizard. This layout wizard allows me to define some post tension cables really fast when I deal with large elements. I just right click on my plate and I can define my settings using this cable layout wizard. I can define the spans between my cables and all of my parameters. And then once I click generate, my cables will be defined on my shell. Once I have defined them, I have the option to define their properties. I can also select one cable at a time, or I can also perform a multiple selection, of course. In the properties, I have several tabs. I have the general tab where I can edit my strands type. I can edit the jacking and the jacking stress and calculate the short-term and long-term losses. I can also enter them or estimate them according to my parameters here. Then I have the shape tab where I can enter my base points and inflection places, onto my cable. So I can see that I can change between an inflection point and a base point. I can see different results on my cable from a list. And what I can really see here is the equivalent force for the strands, for initial losses and long-term, for initial and long-term. I can also have the manufacturing tab and export this into a CAD file. See that I have one already here. I'll just save it like that. And the manufacturing details will be saved into an AutoCAD file. I have it open here, and it is saved as this. I can also add the information to my documentation. I can choose what I want to add and tick the boxes and then click OK. And my information will be sent to the documentation. I have here my post station cable details. Once I have defined my post tension cables, I can see that there are loads created on my structure. So I have load cases automatically generated for initial and long-term losses. initial and long-term, yes. And I can see that it's a predefined type, which is post-tensioning. And then I can add these initial and long-term effects on in my load combinations. I can just go ahead and define load combinations here, where I include my load cases. Load cases generated from the post-tension cables. And of course, my other load cases, which are not defined yet. But in a general way, this is what I wanted to show. Also, in the documentation module, you can export these data for the post-tension cables. Just go ahead and list the tables. Okay, let's move on to plasticity now. Another major feature in FEM-Design 17 is plasticity. You can set up plastic limit forces for different elements in the structure. For the truss members, you can now enter a limited capacity for compression and tension. Up until now, the behavior was brittle, but now it is possible to have a plastic behavior and enter a limit capacity. And you will have a capacity which this truss element will be able to take in compression and tension. Once this limit is exceeded, all the excess loads will be transferred to the other elements. So this is how you can enter a plastic limit for the truss elements. You can also enter plastic limit forces for edge connections in the shell. So if I have some walls defined and I go to edge connection, I select my wall and the edge. I have here the plastic limit forces on the right side where I define the stiffnesses. Of course, those of you who have already upgraded to FEM-Design 17, you are familiar with this. This may look new to people who are not familiar with FEM-Design 17 or FEM-Design at all, or are not using FEM-Design yet. Here you can enter a plastic limit force for the edge connections in my example here. Right now I just entered a value here beforehand, so I won't make any modifications. The same applies for the support, for my support data, for my point, line, and surface connection, and for the fictitious shells edge connections. If I go to line support group and look at my line supports, I can see that the same display is available, and I can enter a plastic limit force in all of my degrees of in all of my directions. I've already performed an analysis, and I can see the reactions here in my supports. I can see that it is limited, and I can also take a look at the connection forces in my edge connection. Set up this limit to 2.5 in this, I think, X direction. So this edge connection will take the plastic limit which I have entered. Please be aware when using this plasticity that you might have to decrease the stiffness of your element, is either a support or connection or a point-point connection. Let me just go back here to the edge connection. You might have to decrease the stiffness here from 10 to the power 7 down to 10 to the power 5, as to allow for deformations to occur. That way, the deformations will occur and the nodes will be able to be activated, and so the forces transmitted. So if you experience this, you might get a equilibrium error. It might be due to the fact that these stiffnesses are too high, and you need to reduce them to 10 to the power 5 from 10 to the power 7. Again, it is to allow for the deformations in the nodes. Everyone is here, and everyone is still tuned in. We have a few other features that we are going to look at during this webinar. And one of them is the simple pile. I have some models here. And now in FEM-Design 17, it is possible to model pile foundation. This is possible in the Foundation tab under Pile. And I can now model these piles with a correct nonlinear behavior. They will have, as I can see here, springs which are defined as line supports. These line supports will get their stiffness automatically from the layer properties, from the soil layer properties. So this means that I will need to have a soil defined before I create my pile foundation. Let's take a look at the piles. These, here I can set the soil springs, and I can see that I also have a plastic limit forces for my stiffnesses. You can also insert, you can have, so as I said, you can have the stiffnesses to be calculated automatically from the soil layer properties, or you can also enter the stiffnesses manually and also enter your plastic limit forces. Let's say, put this plastic limit force here. The line supports are divided along the pile. So you can edit the stiffness as you go deeper into the soil, as the stiffness increases with depth. So you are able to control that. You can also set the pile options in the options menu here. You can have a division length of line supports, which I just mentioned. You can enter the length here. You can enter surface surcharge and select the section parameter to be calculated by section shape or convex contour of section. So now it is possible to model these pile foundations with correct stiffness and get your results on your foundation. Okay, let's move on to another new feature in FEM-Design 17, which is shell buckling. It is now possible to perform a buckling check for shell elements. In the RC Design tab, you have the option to define a buckling region for your shell element. For example, I will set a region and a direction. I can set a direction to be parallel to the local y-axis of the shell. I can set it to local x-axis of the shell, or I can also define a direction myself. So if I choose this and then I select my wall, I first enter a direction, and then I select my buckling region. And I can see my buckling length there, and with the beta value. Or I can choose to have it in the local y-axis of the shell, which is by default. And I select my wall and then enter a buckling length like that. I can, after I'm finished entering my buckling lengths, I can perform a check also on the wall that I've just defined. And I can see the utilization in my utilization table. You can see it here under shell buckling, and I see the utilization. I can also take a look at detailed results. So if I go to new result and go to shell buckling utilization, and I can see the utilization in a color palette on my shells. You can also add some results to the documentation. So if you go to the documentation module, you can select the table and go to RC Design, load combinations, or maximum of load combinations, and choose shell buckling. and you have the results. You have some results listed as the table, as a table. Let's move on to the next feature, which I want to show, which is steel joint stiffness. It is now possible to calculate the stiffness of your joints on your 3D structure and then apply it to the structure and then calculate with the correct stiffness. So right now I have a steel structure and I have defined some steel joints and designed them. I have now a stiffness option here in the Steel Design tab under Steel Joint. I have the stiffness. Here I can see that the rotational stiffness for my joints is calculated. And I have the option to apply it or not. I can also apply it individually or say apply all. And it will be applied to my structure. I can choose here. If I select a joint, one of the joints, I have different options to apply this stiffness. I can use the steel joint stiffness of the load combination which I select. If I have several combinations, I can choose one of the different stiffnesses that are calculated. I can allow it to just use the stiffness with the highest utilization, and I also have the option to enter it manually. So if I know the stiffness of the joint, I can also enter it manually. For now, I'll just use the highest utilization. Okay. If I select apply all, and then I can run apply design changes and recalculate. What I notice is that once I apply the stiffness and I go to my 3D elements connected to that stiffness, I can see here that the value is set to the release end in my elements in the Y direction. So the stiffness is applied to my elements connected to that joint. So if I have this, I have the stiffnesses applied to my structure now, and I can calculate. I can redo the calculation with the stiffnesses applied. So I don't have too many combinations, so it won't take too much time. Now, so we'll get the results with the correct stiffnesses. I can also see the calculations for my steel joint stiffness. If I am in the steel joint stiffness utilization, the joint utilization results, I can go to detailed results. If I right click on my joint, I will see the stiffness calculation along with all of the other checks in my documentation. So I see here the stiffness being calculated with all of the parameters. Of course, those of you who are familiar with steel joint, you know that you can manually design the steel joint. So once I have created a joint, I can manually design it and edit the components of this joint. I can enter the end plate, the stiffeners, top stiffener, bottom stiffeners, and diagonal stiffeners if I want to. And of course, the properties for my beams, for my beam elements, the haunch, end plate, bolts, welds, calculation, and stiffener. So I can edit these parameters, apply them to my model, and have my stiffness recalculated according to my design. I haven't modified anything. No, the values are the same for now. All right. And the last feature that I want to present today is the fire design. Major feature in FEM-Design 17. Going to have a model here. The fire design for steel elements is available in the steel design tab. Just as the other tools, I have it here, steel bar fire design. Here in the steel bar fire design, I can enter and set my design calculation parameters for my elements. Here I can choose duration of fire, a temperature curve according to Eurocode, time step, section exposure, all sides or different sides, and my calculation factors. Once I've set up these up, I can perform a check. And I can actually see the utilization of my elements for fire action without any fire protection. Right now I don't have any applied fire protection, so I can see the fire behavior for my elements under the action, under the action of fire, without any fire protection. I can also go to new result and see the fire design, utilization, and see my detailed results. I can see here the calculation for the fire, and it is performed without any fire protection so far. I can apply some fire protection using auto design. I can select my elements and choose a material from a library of different fire protection material. You can choose a minimum thickness to be applied and a maximum thickness, and choose the thickness increment for which to calculate for. I can also calculate to maximum temperature and set a limit utilization of my choice. All right, if I choose to perform a fire design, I have my parameters set, and I select all of my elements, and I choose design, and all of them have now a applied fire protection. I can see here the applied fire protection with using the material that I chose and the thickness which best applies. And again, I can take a look at my detailed results and see the calculations for an applied fire protection. These are the major features in FEM-Design 17. There are, as I said, there are a lot of new elements implemented. For now, I just presented the major features of for FEM-Design 17. For our users, I recommend that you upgrade to FEM-Design 17 to have access to the features. And you can do that by going to help and check for upgrade directly from the program and download the new version. For those of you who are not using FEM-Design yet, please go to strusoft.com under FEM-Design and get a free trial version. You will get the latest version with a trial license for 30 days, and you can test the programs. You can test the program on your projects, and we will be here to guide you with any questions that you might have.